We can also calculate confidence intervals to estimate population proportions. Now first of all, remember point estimates. The value of any statistic that estimates the value of a parameter is called a point estimate. So what we're going to try to do is take a point estimate, the sample proportion, and create a confidence interval around it to estimate the parameter, which is the population proportion. So here's my example. In a recent poll of 200 households, it was found that 152 households had at least one computer. Estimate the proportion of households in the population that have at least one computer. Now our sample proportion is pretty easy to find. It's just x over n, or 152 over 200, and we find 0.76. That means in our sample, 76% of the households have at least one computer. Now this is just a single estimate. We took, one sample of the entire population, just one sample. So it's probably off from the actual value of the population proportion that we're trying to estimate. Because of this, we're going to create a confidence interval to give a more realistic impression of what the actual population proportion value may be. So first of all, there are two requirements for constructing a meaningful confidence interval about the population proportion, and that is, first of all, the size of your sample has to be no more than 5% the size of the population it came from, and secondly, this weird equation right here. If the sample meets the requirement put forth in this equation, it means that it has approximately a normal distribution, so we can compare it to the normal z distribution using z-tables and stuff like that. So first of all, back to this example, I want you to construct a 95% confidence interval to estimate the population proportion. Now first of all, we have to check if it meets these two requirements. So the first one, yes, 200 households is definitely less than all of the households in the world, definitely 5%, less than 5% of all the households in the world. And second of all, our equation, we find that 36.48 is greater than 10. And don't get too caught up with the meaning of that. Just realize that because it's greater than 10, it means we have approximately a normal distribution, and we can compare it to the normal distribution. So I'm going to take that away, and now we're going to use this equation to calculate the confidence interval. It's still just a point estimate plus or minus a certain margin of error. So here's our equation, and remember we want to calculate a 95% confidence interval. That means we have the 95% in the middle and the 5% left over that's split into those two tails. Now what's split into those two tails, the part that's left over, we're going to refer to as alpha. Alpha is the probability of making a type 1 error, but don't worry about that right now. Just realize that 5% is the part that's left over from our 95%, and it goes into the tails. So like in the equation, you see z alpha divided by 2. Really, that's just saying, okay, z 0.05 divided by 2. That means what is the z-score going to be when there is 0.025 in one of the tails? So, and we have this table right here. We go to the z-table, and if there's 0.025 in the tails, that means there's 0.9750 in the body, and that means we're going to use the z-score of 1.96. Hopefully that didn't just confuse you. I've already talked about this a few times, so I don't want to keep going over the same point, but if you look at the lecture on z-scores, it might be a little bit more clear if you didn't understand this, where I got this 1.96 from. So we have this, and we're going to use the 1.96 for our z. So now I'm just going to plug things into the equation. That should be a square root at the top, kind of got cut off. But you can see I put in the 0.76 for the sample proportion. I put in 200 for the size of our sample. And then I put in 1.96 for our z. And I found what we refer to as the lower bound and the upper bound. So for our confidence interval, I am 95% confident that the proportion of households in the population with at least one computer is between 0.701 and 0.819. And that's how you construct a confidence interval around a population proportion.